Welcome to the HoloViz tutorial. We will be presenting it both James Bednar and me. I'm going to show you the tutorial first, and give me a second, and I need to present my screen. Okay. The tutorial can be accessed online using this QR code. There are some links here, but we'll start with this QR code. This will allow you to download the tutorial, and James is going to start the tutorial. I'm going to start the beginning. We're going to do it in 3 ways. First, we're going to introduce what HoloViz is. And James is going to do this because he's from Anaconda, the company who develops it. Afterwards, I'll take over some of the presentation elements, and I'm going to try to explain some HoloViews, and then I'm going to show you how I present panel presentations with it. How I create presentations using panel. Panel is one of the HoloViz tools. So without much ado, I'm going to go back and stop presenting, and James, the screen is all yours, and start by presenting exactly what you do and what HoloViz is. I didn't tell the secret.
Very good. Thank you, Jake. So, yes, I'm James Bednar. I do work at anaconda.com. The work that I'll be presenting actually started in an earlier life when I was a professor at the University of Edinburgh working on computational neuroscience modeling tools. And we struggled with tools that were available in Python, and we wanted our lives, paradoxically, we wanted our lives not to be spent wrestling with visualizations, and we wanted to instead focus on the data. And we achieved that while we were scientists, but now we got hired by Anaconda, and now we spend all of our time working on visualizations. So I guess it didn't work out for us in the long run, but it should work out for people who use the tools. And HoloViz is a suite of tools that are designed to help you kind of level up how you approach data and visualization using Python. And so it's not completely novel. It's all built on things that were already around, already available in Python, but it's a way of treating things at a higher level where you do a whole lot less work and get a whole lot more power. And I'll try to demonstrate how that's true and what that means for you. But the goal is that you start with some data and you spend very little effort, and immediately the data gets on your screen and into your eyeballs and into your brain. We're trying to make that process, whether that data is modeling data or measured experimental data, whatever it is, try to get it into your brain effectively as quickly as possible, and all of it is into your brain if possible. So everything I'll present is from holoviz.org, our main website. And HoloViz is kind of a meta project. Down here are most of the main projects that we work on. These are all different tools available from HoloViz. HoloViz is open source. It's entirely free. It's all licensed for commercial use if you want to, or academic use. We make no money off of any of it. Pretty much at Anaconda, we do these things because they make Python more powerful, and Anaconda makes money when Python is more powerful. But we certainly don't make any money on these tools. These are all just available for scientists and analysts to use. And so I'll talk about these various tools a little bit. If you want to follow along, what I'm presenting is in this section called Talks. I'll be presenting this material that's in the Talks section of the website. And if you want to run it yourself at home, you follow the installation instructions. So it's all freely downloadable. You can all run it on your own machine. And it should run the same for you as it does for me. And you have the copy of it at the website to show what it's supposed to look like when you do. So now I'll switch to actually running it. All right, so basically our claim is that no matter what you're doing, you ought to be looking at it. You ought to be seeing it in order to make sure it's right, to understand it. And I'll try to break that claim down a little bit. And these are the tools we use to try to achieve that. So in the corporate world, this is presented as from data to decision. In the academic world, it's kind of similar though. You ask a question, you get some data, you explore the data, you model it, and eventually you communicate it somehow. And then as soon as you do, that leads to new questions, and you start over. Basically, it never ends. But our point is that every single stage of these, people a lot of times they think of visualization as being this last stage here, communicate the results. And by that point, it's far, far too late. If you have not looked at your results by then you're almost certainly going to have results that are not true, that are, you missed all the important stuff because you didn't look at it, and you're going to misrepresent it. That's my firm belief. You ought to be trying to, not at the end trying to visualize, but you ought to be trying to visualize at the very start, as soon as you possibly can. And so these tools are designed to make it as easy as possible to visualize throughout, from the very start, so that you don't think of it as something, oh, I got to do it to make my nature paper. You ought to do it as soon as you see your data, in our opinion, and we try to make that easy. And so if you're using Python, first, the good news is there are lots of tools you can use. And so in principle, you can visualize anything. In practice, it's actually immediately a problem. Immediately Python, you say you've got some data and you want to visualize it. Immediately you have to look at some plot like this and say, oh, okay, what do I even do? Do I pick one of these tools? Do I write my own tool? Do I pick a non-Python tool? Very few people have tried all these tools, know how they work, know which one to choose. It's a big pain. And so what we've done is focus on a subset of the tools we chose certain tools in that list to focus on and say, these are the ones we're going to promote and try to make things better just for those tools. We can't make all tools better. We can't advance on every front at once. So we picked a couple of main tools, and those main tools are Bokeh and Matplotlib. These are both very well-established libraries. When we started, Bokeh was actually new, but we started a long time ago. And now we started our first projects were actually in 2003. Our first ones that we're building on Matplotlib were probably in 2005. And then we've been building on Bokeh for the past 5 years as well. So these are both quite well-established libraries, and we're building on the capabilities they provide, but trying to make them much more easy to use, much more powerful, and able to handle larger data sets, to be interactive, and so on. And we're doing this all in the context of a browser, a web browser. And so because we're trying to focus, we come from a background in doing supercomputing simulations where the data is all crunched far, far from us in some data center we've never visited and we don't have access to. So we need to be able to do remote visualization of large data sets. And so we don't consider any tool unless we can use it via a web browser. So some of these tools, like the ones bottom left here, those are focused on running on your local desktop machine. We ignore all those tools. We're only going to tell you how to use things that are compatible and work well in web browsers. And so what are we trying to do? I think I've already pointed to a lot of the goals here. The first one right here, as I mentioned, we need to have it working in browsers. The second is we're programmers, but we don't think you should have to program at every step just to see your visualization update. We really want to make it be easy to have interactive plots so that you can think, oh, what's that data point over there? Or what if I zoom in here? Or what if I select this thing? So you don't have to have that thought and then write some code. You should have that thought and immediately get the answer. And that makes a much faster exploratory process, and it makes it much easier to understand your data. And so we're only going to consider things that have at least the potential for interactivity. And we're focusing on people who know Python. If you don't, well, you should learn Python. But we're not focusing on people who are already web programmers, people who know JavaScript and are familiar with a lot of JavaScript web development frameworks. Those people can make interactive plots. That's true. But they do so with a lot of code and a lot of background that isn't typical for a scientist. And so we're focusing on doing things at a higher level, focusing specifically on Python users, staying in Python, not switching to some other tool, some other web-based tool. Stay in Python, but view it on the web. Actually, this presentation is running in Python, and it's being viewed on the web. So, and let's see, starting with, we just want the data to become available immediately, the data of any size, because we were sick of having to switch whenever we got into some data set that was too big for us, having to switch tools, or to even worse, subsample the data and throw it away. Like all this expensive data, the first thing you have to do is delete it and then visualize? No way. So we want to make sure that our tools are capable of working with data of literally any size. If you get large enough data, then you have to throw a bigger computer at it maybe. You have to buy some time on Amazon or use a bigger queue at the supercomputing center, but it can still handle any size. And even a laptop is enough for quite large data sets with these tools. And we're building all on what's available in the SciPy and PyData ecosystem. That was a very small ecosystem when we started in 2003, but it has grown amazingly over that time. And so we try to always not do things that we don't have to, and try to build on what other people have done, because there's a lot of people doing work in this area. So we can do some really cool things by stepping on their shoulders. And we focus on two-dimensional plots. There are some that are very 3D based. That's not really our area. So if you really want to do 3D plots, you can probably tune out now. We're not going to do very many of those. We do a little, but really we're focusing on people who are visualizing arbitrary data with some dimension against some other dimension, not people who are just trying to view a model of a car or something like that. So that's a different field called scientific visualization. We're actually working in information visualization. And then finally, the last kind of principle we have is we don't want to mix up your data, code, and visualization. And that means that if you have some particular data, we don't want the code that you write to be tied to that data so that it only works with that data. We want it to be reusable code. We don't want you to have to rewrite that code depending on whether you're working in a Jupyter notebook, whether you're working remotely on a batch job, whether you're working locally with headless, just running a process. We want the same things to work in all those cases because we're sick of having to rewrite things. And so we want to provide you, if you are in an interactive environment, you should be able to easily make widgets to go along with your plotting to provide interactivity. But if you're not in Jupyter, you should be able to set up a server that can speak to the public or to your colleagues and share all your results. And the same stuff, you shouldn't have to write it again. You should write the code once and then use it in Jupyter, use it as a server, and also export to a static web page. And actually, Jacob, when he shows his, that's an example of developing it and then exporting it to a static page that doesn't need Python. So you can share it as widely as possible, just give it to anybody. And so this is in contrast to some other approaches that really rely solely on Jupyter, which is only going to work when there is Python available. So we try to use Jupyter, but we don't depend on it, don't require it, and we use it when it's there, and we don't require it when it's not. Okay, so let's get started. First off, we're going to assume you start with some data, and it doesn't matter where you got the data. You have to have some data in Python, and as soon as you have that, you're able to get to work here. So the typical standard way that people would start in modern times, now this wasn't true when we started, there was no pandas when we started, but nowadays, if you have a pandas data frame, that's a good starting point unless you know otherwise. You shouldn't use a pandas data frame if you have multidimensional imaging data. So if you do microscopy and you have a huge stack of scans, use X-ray instead. All these tools will work just as well for X-ray as for pandas, but for this example, we're using pandas. So if you have Python, this is actually a running Jupyter notebook, and so if I execute that, this code cell, it'll read this file, and it'll show me the first 5 rows of the file. And it shows that this particular file is a data set of disease incidents. In this case, it's indexed by week and year and state. And it shows that for that week of that year of this United States state, the incidence per 100,000 people of measles was approximately 4. And there was no data on pertussis for these particular records. And then for various other weeks, there's different values. So again, this is a data set. It could be any data set. We just have to have some data set to work with. And so in this case, it's basically measles incidence over time. So Pandas has this plotting functionality called the dot plot interface, and it's great. In this case, it doesn't immediately work very well, because if you do plot on this data frame, it tries to plot the week, and the week is always between 0 and 52. Well, 52 divided by 7, whatever that is. So yeah, 0 and 52. The year is always, for this data set, is always in the 1900s to 2000s, because that's when the data was collected, and then the incidence is down here. So it's plotting all of your data, but this is not a plot anybody would ever want. It's not very useful. So you have to actually use some smarts. So let's say you use some smarts and you get a plot that's usable. You have to learn a little pandas. I'm not going to tell you any pandas in this talk, really, but if you do use pandas, you can aggregate it so that you come up with a single value per year. And if you have that, then you can easily plot it. Then you get the measles incidence per year. And this is all using the matplotlib based, no HoloViz tools whatsoever. This is just standard Python pandas plotting. So if you do this, you can see that, oh, measles used to be highly variable, but also very bad. And then somewhere around the early 1960s, it took a dive, and then it quickly became negligible. So that's immediately, we went from a set of data that we did just a bunch of numbers. There are lots of numbers. How many are there? Let's see. Looks like there are 222,000 observations in this data set. So that's a lot of states and a lot of weeks and a lot of years. Very hard to make sense of it as a table. You can just scan it and not get much out of it. And if you do a pointless plot, you can see the data, but still not get much out of it. But with a little bit of work, you can get a meaningful plot. And here, this tells you something. Measles used to be common. No, it's not common over all the states. So that's a success. That's visualization telling you something useful about the data, and it's consistent with reality. We know that measles used to be a bigger problem, and so on. So that's a good start. But what we got here actually is just a static PNG. If I were to drag that into my email, I could send that to somebody, but that's all I can do. I have this one thing here, this static output. And that's what matplotlib is designed to generate here. It's deliberately being used to generate an image and display an image. That's great. But I want to do more, because if I wanted a different image, I would have to start editing this cell here. I want to try to avoid coding, and I want my users to avoid coding when they can. And so I want them to code when it's appropriate, but not when it's not. So if they want to change anything about the plot right now, they'd have to go back to that. So let's see if we can make that interactive. Okay, yeah, here's the point. I happen to know that I looked it up. Measles vaccine happened in 1963. And so somewhere around there, measles started being eradicated by vaccine in America. So that's a good way to validate that this is a appropriate plot. Okay, so now we'll start using some HoloViz tools to look at that same data. All we have to do is to import hvplot. In this case, hvplot.pandas is our interface to pandas. If you wanted to use Xarray, it'd be hvplot.xarray. If you want to use Dask, it'd be hvplot.dask, and so on. There are lots of things that hvplot supports. We'll focus on pandas. If you do that same plot, you get a similar display, but now it's an interactive display. And so now, if we wanted to actually get the data out of it, we can see exactly what the data is. You can see each individual data point. We could zoom in if we wanted to look closely at what data values are available. We can zoom in closely on that. If we wanted to really see the differences clearly, and so on. Now, there's not much to do in this plot. It was actually pretty clear already, but hopefully you get the idea that in an interactive plot, if there was a lot that you can't immediately see, you can zoom and pan until you can see it. And so immediately, if you can get an interactive plot, it's more, you don't have to go back to the data necessarily. And we'll show that in lots of cases. So anyway, that's so it's the same pandas.plot API, but from hvplot. There are also ways to make matplotlib be more interactive, but Bokeh is fully interactive, basically giving you control over everything that you see here. You can tie events to each one of these data points if you wanted to. You can make a selection here and have another window pop up. There are all sorts of things you can do because it's fully browser-based interactive. Here's some of the things that we expect our users to be able to use. Let's say you've got the plot that we just got here. This is a plot, or it displays as a plot, but it's actually an object that you can work with. It's not a dead end. So let's go ahead and here's the same code that I just showed, but now let's go further and take that plot and overlay. That's what this little symbol means, to overlay, i.e. to put something on top of something. So we're going to overlay a vertical line. In this case, it's a vertical line at 1963, a vertical black line at 1963, and overlay some text that says vaccine introduced in 1963. And now we're starting to put some meaning on this data. And let's say I looked up when that was. Now, if I came back to this a month later, I will have forgotten when it was. But now I can never forget it. I can see immediately, oh, the vaccine was introduced here, and immediately it had an effect. This was just as easy to make as your original plot, but now it's able to collect more things together. But we haven't lost anything. If we look inside this plot, we can see that it's an overlay of a curve and a vertical line and some text, and you can learn about what all these things mean. And if we look specifically inside the curve and we look at the data inside the curve, we see that we've got our measles data again. This is the actual numerical data that we can select out of here. And now we can make a totally different plot if we wanted to. And so by plotting something, we never have, even in this complicated form where it's got all these other things overlaid, we haven't lost anything. And so that's what the whole HoloViz approach is trying to let you do, is make things be visualizable as soon as you can, and then never look back. You don't have to rewind and redo it again. You just keep going forward. If you need to keep working with this data, you can always access the data, even though the data itself is always visible. Like if you return the data, there it is. There's your plot. Remember, it seemed like it was a plot before. It wasn't a plot. It's this composite object that displays a plot. And you can always get all the data out of it. You can always pull out the line if you want. You can put in a new line and so on. That probably isn't that clear, but it becomes clear the longer you work with the tools that we're trying to get you visual immediately without ever having to leave the visual behind. You can take this representation, you can subsample certain years from this, what seems like a plot. You can select that, you can move forward, you can aggregate it, you can do all sorts of stuff, and I'll show a little bit of that. So we can certainly get the original data. We can also, well, do all these things that set out here. You can lay them out, you can slice them, sample them, change their colors, whatever. Like let's kind of do that again. And in this case, let's start in the previous case, we aggregated everything down to being a year versus measles, which means we lost the values of the states. So let's do it again and try to preserve more of that information as far as we can. So let's start with the data and preserve both the year and the state. And so otherwise it's aggregated now by 2 indexes, by year and by state. Previously it was just 1. And so all you could do is plot the year and state. Now we have something that we can plot the year and we can plot it all. Here it's, again, we're overlaying a vertical line, and we're going to plot, in this case, we're going to group by state. And what actually happens there is it groups by state. It means that it's going to plot each state's data individually, and unless you don't tell it anything else, unless you tell it something else, it's going to give you a widget. So which state? I've grouped it by state. I only know how to display a plot, but I have 50 plots. What do I do? What it does is give you a widget, and now you can select which state. So now previously you would have had to select the state by coding it. You don't have to select the state by coding it. If you haven't chosen your state, but it's grouped by state, Well, you can choose it when you plot it. You don't need to do it ahead of time, and you don't need to type any code. If I want to plot Colorado's data, I'd plot it, Indiana or whatever. And so we give you these things. They still work just as well before. You can still overlay a vertical line or text. But now you're overlaying it on 50 plots, and then you select one of those 50 plots to see. Hopefully that makes sense. Again, Jacob will show some examples of doing all this for his data. But if we've got, let's say we've got this by state. This is this object we're working with. If we've got that object, you can see that all the state data is there. Can you get it out? Well, of course you can. Here, let's pull out Texas data and put a label on it, and New York data and put a label on that. And then let's use this operator, which puts things side by side. And now we can see the Texas data next to the New York data. We can put anything we wanted here. And if I can spell it right, I can do it. Oh, but I've labeled it New York, so it's confusing. But so let's turn that back to New York data. But anyway, hopefully you can see you've got this data structure that's got all your data. It's visualizable all by itself, as here. Or you can pull out anything you want and visualize that. Or you could pull out a certain date range or anything. So it's a way to take your data, wrap it up, make it immediately visualizable, and then work with it all you want. That's the whole point at that point. We could pull out 4 of the states if we wanted to out of this. And we can overlay them in this case. Overlay them is using an operator called by. It's the same as group by, but by gives you an overlay. Group by gives you a widget by default. You can change it, but that's our typical. Either group it by the state or literally do it by state, and then you'll have it by the state. Of course, we only selected 4 of them because if we overlaid 50 states of data, it'd be a mess. But you can choose whatever is appropriate for your data, but it's super easy to pull out something and visualize it. Or if we have those 4 states, if we didn't want them, I said it was just a default that it overlays it. If you don't want it to overlay, you can tell it to, instead of doing by, you tell it to use call in this case, so that it does all the states in the by column. So it does 4 different states, each of them in its own column. And so it's the same data, and you can see it's still overlaid with the same V-line, same vertical line. So you can see how the introduction of the vaccine took a little bit longer to have an effect on my backwards state of Texas than it did on New York, where it was immediate, and so on. And obviously the charts that I've shown are line. You can do any kind of plot. You really don't have time to get in all of them. But let's say you wanted to work a lot. You could come up with a plot like this. And I'll break it down a little bit just so you see what's going on here. So this is a plot of measles by state. So you can see each one of the states is here. By year, that's just off the screen here with this zoom. But the year is going from the beginning in the early 1900s to today. And then around here is the vaccine being introduced. You can see that it varied it by state, but eventually petered out and now has become very rare. Actually, more recent, there are a few blips nowadays recently when people stopped taking the vaccine. But these cyan colors are very low values, and the darker colors are very high values. And it's very low values. You can aggregate across a vertical column here. That's what you get to this line. And then the error bars shows you how much diversity there is in that column. And then you can see that when it became low incidence, it also became low variance. And now it is both low incidence and low variance over time. All of this is from these lines on the previous slide. And also it's code that it might look unfamiliar, but you can actually map it directly to what you can see. First, we create a heat map. This is the first part of it. This is a heat map by a state versus year. So it's a state versus year heat map, and you just say it's a year. Well, it's a year versus state. I guess state versus year heat map is how you read that. Plotting the measles incidence, and it's computing the sum of all the values across the different states. and it's got a logarithmic axis and some various other options. Oh, okay, that's why it's state versus year, and that's because and the y-axis is flipped. Anyway, so that's the heat map. It's also been aggregated by year, so ignoring state, that's the value underneath it. This value down here is this blue curve, that's the aggregate. The aggregate is aggregated over state to get one value, and the aggregation also computes the error bar. So if I go back to where so you take the heat map here and then you aggregate it by year. So combining over everything except year is what that does. It takes the mean across all states, and that's what it's plotting for that blue line. And then we add in some error bars and overlay them on that curve. That gets us this ag data structure. We set some options, and that's what it's showing on the bottom. That's this plot. And all we need now is this arrow and the text. And here's so we created some text. We put it at 1963. We put it at incidence of 800, just to make it be in the middle. And this is the code for an arrow. And the words "the vaccine introduced." And that's it. That's how you make a pretty complicated plot like this. You do this, you construct this out of that one, and you set some of the plot options. So obviously this is not something you do on day one. This is something eventually you do as you're gearing up for a publication. But even when you're gearing up for a publication, it doesn't necessarily mean a whole lot of code. It means a lot of thinking about the options that you want. How do you want to display this information? What makes it clear? How can you put a lot on the screen and tell a good story? That takes a lot of thought. We don't want to say that our tools mean you don't have to think and you don't have to do work. You do, you just don't have to do a lot of coding. So everything so far has been done with bokeh. You can do the same things. You can tell HoloViz tools to use matplotlib as the backend to render the plots. And if you do that, you can still use interactive functionality, except that matplotlib itself, when used this way, is not interactive. It's still a PNG. You can still drag that into your email. But the things that HoloViz does are still interactive. The HoloViz creates this widget and lets you select, and just each time it selects, it's selecting a different PNG. So it still works if you want to use matplotlib, which is everything originally was built around matplotlib, but then we've moved more towards building on bokeh to get more interactive functionality. People who focus primarily on publications might want matplotlib. It's a really long history of publication quality output. Bokeh is a long history of interactive output, and so they both do both, but one's better than the other for your needs. All right, that's kind of the tutorial part of this presentation, and the rest is kind of showing you stuff but not getting into details as much. I'll just show you a few more things to show that basically what we focus on a lot is that you've got a lot of dimensions in your data, and you're trying to, the work in making a visualization is to take some complex multidimensional data set and then map it onto things a human can consume. And we have some nice already canned ways to do that, so that if we, like the scatter matrix, and it's pretty easy to actually build something like this by hand. This is one that's already built for you automatically, but it just shows you every variable against every other variable. And so if you find some data points that are interesting in sepal width versus sepal length, you can see how those same variable data points relate to everything, all the other data points. And here it's colored by species. So this is the well-known iris data set, a bunch of different flower species, 3 different flower species, and a bunch of different samples of those species, and showing how they relate along these different dimensions. And so if you want to explore data like this, where you've made a bunch of observations, that's already quite easy to do. And then going on from there, is when you start pulling in other HoloViz.org tools. So far, we've really focused on HVplot. HVplot is built on HoloViews, but we recommend that most people start with HVplot. It's a much quicker inroad, particularly if you already know pandas or NumPy or Dask or Xarray. Well, with NumPy, actually, HoloViz is probably fine. But if you know pandas, then it's super easy to get started with HVplot, and it can do most of the things you want to do. Anyway, the rest of the stuff relies on these other tools. GeoViews is if you want to have anything to do with geographic plotting. If you don't, happily ignore that, because that requires a lot of external libraries that you don't necessarily want to install. Datashader, I'll demonstrate that in a second here. That's for how we can claim to deal with arbitrarily large data. Skip over param because it's too hard to explain. But panel is great. I think Jacob will show you some panel stuff. Panel, it lets you build apps, basically. So if you want art, you already saw a little app with a widget, but that was CAN functionality. What if you want custom control of this widget does this thing? Panel will let you do that, whatever custom anything you want, while still doing it all in Python. So for this last little bit of the demo, let's look at a data set of earthquakes. This is just a bunch of GPS locations. You can study this code on the website if you want. Essentially, all it does is load it, declare a background map, convert it into, project it into the map, and then display it. And so it's displaying it with a certain fire-based color map. And then what this did here is basically point plot a few million data points on a map. And as you can see where those the colorful fire-colored things are where the data points are located. But if you zoom in on them, you'll be able to see individual earthquakes wherever they were located, and you can say find some hotspot. As you zoom in, what happens here is that Datashader is being called in Python every time you zoom in. So I'm in a browser, I do a zoom, and you can actually see it flicker a little bit. It's probably zoomed. It's probably called Datashader 10 times in between zoom events. And so there are 2 million of these data points. When I zoom in, their number is decreased, but each time I'm asking Datashader to render an image of them, and that's what I display in the browser here. So Datashader does that outside of the browser, and that's why I can handle very large data sets, up to around 1 billion on this MacBook Pro laptop, or more if I have a cluster or some cloud resources. So all that's happening here is that each time I zoom in, it'll re-render the data, and I can show arbitrarily large collections of data, work easily with millions and billions of data points, and still be fully interactive in the browser. So that's all done by this one little word called Datashade equals true. That's what makes this possible. So you can see all these patterns, and if you were to throw away the data and subsample it, you wouldn't see any of the patterns. You also wouldn't see these rarer events. But with Datashader, you can see them all. Lastly, I'll just do a tiny little demo of a panel application. And so you can take that same code, we can turn it quickly into a little app. And this is an app, I just named it Earthquake Explorer. And what it does is take this function that plots, and then it has a couple of parameters. In this case, the parameter is a color map and an alpha value, that's transparency. The alpha value determines whether the map is visible. And so it's got a couple of parameters, and well, 3 parameters it looks like: color map, alpha, and reverse. And I can reverse the color map and change that. I can choose a different color map, and so on. So those, obviously nobody needs to change these particular parameters very much, but you could change any parameter of any function. And the function, remember, was right here. We wrote a little function that returns something visible. As long as you can write a function that returns something visible, and the function has some parameters, color map, alpha, and reverse, And you can very easily make a panel application that lets you, instead of writing code, you just select it. You don't have to type color map equals gray. You just select it and do what you like. So it's a much faster, much more efficient way of exploring and understanding your data. If you can so quickly make an app rather than have to do all the programming just to see each of the combinations. All right, that's it for my main presentation. See on time. Let me get out of this view, and then and then just point you to something which is, if you want to see anything more, just go to examples.pybiz.org. There are lots of examples of all these tools. Hopefully there'll be one that fits your particular situation, and you can see the live running versions of anything from there. So I'll leave you with that.
James, before you go away, can you go back to the HoloViz website where it shows all of the application, all of the small little tools that you create? Yeah, this one. Can you explain? Yeah, can you explain in simpler words what are the differences between those? Because this is something that you should explain.
Yes, that's a very good question. It can be very confusing. That's why I try to say HoloViz a lot, and I try not to say these other tools, so that later on people can go to HoloViz and read all about it and learn the difference. But to summarize the difference, or what's going on here, if you do .hvplot, that's hvplot. So hvplot, if you go to that, it has its own website. You don't have to use any other tool. You can just use hvplot. And hvplot just takes data in lots of different formats. These are all the formats that it can support, and you call .hvplot. And then what hvplot does is translate that into HoloViews. What HoloViews does is translate that into bokeh, or if you need data shader, it feeds it to data shader and then feeds that to bokeh. So hvplot is kind of like your master control of everything. It's the one package that you only need to know its API, and in fact, you already know its API if you've used pandas.plot API. And so that we recommend users start at hvplot, but it would never work without HoloViews, bokeh, and data shader. But you don't have to go to their websites and read about them until you run into some problem like, oh, I wonder if I could do this. Yes, you can. Check HoloViews, you'll find a way to do anything. And if you don't find it there, check bokeh. There'll be a way to do it. And so no matter how obscure your need is, you can drop down to these lower levels. It's just, we hope you don't have to do that very often. You should be able to spend most of your time at hvplot and just trust that hvplot is going to take care of it using these other tools. So that's hvplot. hvplot is actually, it's not mentioned there, but it's built on Panel. And Panel is what lets you lay things out on the screen, have them communicate with each other, and communicate between the browser and the Python process, and wire widgets together to control all of that. So Panel is the little apps that you saw me do. Those were actually tiny little Panel apps, automatically generated by hvplot, essentially. That's one way of thinking about how that works. But if you want to make your own apps and completely control everything about it, that's when you'd use Panel. And then GeoViews is exactly the same as HoloViews, but it depends on a huge stack of specialized geographic specific libraries. So if you want to convert from polar coordinates into this, under this assumption of the Earth's curvature, GeoViews is your library. If you don't use GeoViews, because GeoViews depends on a lot of old Fortran code, a lot of old libraries that are fairly difficult to install. So most people can use HoloViews. And in fact, everything I showed uses only HoloViews. You can put things on a map without GeoViews. It's only when you get into the obscure coordinate transforms that you need GeoViews. So I would recommend avoiding GeoViews until you need it, and you know you need it. And when you do, it's not that hard to install, and it saves you a lot of trouble. But if you don't need it, don't install it. And then Data Shader is its own project as well. You can use Data Shader all by itself. Like this is Data Shader's own API, just given a database, a data frame where each data point is one person in America. This is what Data Shader generates by default. It's an image. It's not interactive. It has no axes. Bokeh is what adds the axes. So we use HoloViews to work with Data Shader to render the data, and to work with bokeh to provide the interactive experience. So Data Shader powers the big data plots But you don't have to worry about it if you use htplot. Just say datasheet equals true, or rasterized equals true is actually what we usually recommend. And then all of these are built on this library from 2003 that we made when we were neuroscientists, called Param. It lets you write code that just is so much easier to maintain. And it lets you write panel apps that work, that are really smooth. You don't need it until you've already been convinced by these other libraries. So don't worry about that. And then it's a requirement of all these other libraries. You don't need to learn about it though. It just works. And then finally, ColorSet is its own library. You can use that even if you use nothing else here. ColorSet is basically focusing on one thing, which is making sure that your representations, your visual representations, are scientifically valid, perceptually appropriate for our visual system, unlike previous versions. These are the bad ones before, and they are big areas that you can't distinguish between. These are all perceptually uniform maps, including this one. This is a bad one. It looks like it's blown out. The same data, if you display it with a good map, you actually see tons more detail. All around this Chicago area, you can see detail. If you look in the other one, it's all washed out because humans can't perceive fine differences in those colors. And so it's a way of not doing this. Yeah, just look at what happened in New York. It's just all a mess. It's not a mess. There's very strong peaks around this, specifically in New York. You can see it if you use these color maps or any other perceptual uniform. This is a collection of dozens of them. And those are the main ones. And then we've got another 10 that I won't talk about that are needed for all of these tools to work. It's a lot of work.
Well, thank you for this, and I'll take the presentation from here, but at this point, if anyone has questions to James, please ask them now. I bet you have questions, because I remember I saw this presentation about 2 years ago. I had questions.
You can keep asking me in the chat. If you have any, I'll hang around in the chat for a little while while Jacob gets set up. But if you have something that really deserves clarification, just ask it out loud now.
Maybe just to check, you mentioned, I think, that you could export these as essentially a standalone HTML page or something. Is that right? And that's even the panel apps and...
That's right. And so for a panel app, let's say one standard thing we do is say just sample the space of possible widgets. So if you got 3 widgets and each of them have 50 states, we suggest maybe sample 3 states per widget. And then you have 9 states and you export all those states. And at that point, you have no need ever to call Python because you've captured all of those combinations. And you get that as a static export. And you email that to somebody and they never have to ever know you use Python. There's no server involved, and Jacob uses that extensively. And so you can use that with panel or with HoloViz stuff. If it's a manageable set of things, you can deliver it. If it's unmanageable, actually, I think Jacob's stuff is unmanageable, but he tries to capture so many combinations.
I'm pushing them to the limits. But what I'm going to show you, and even this presentation, is actually a static web page, and we're going to talk about it a little bit.
Yeah. And almost all of our websites are also just static web pages. They're just published to GitHub. GitHub has a web server. I don't even know what it is. It has no knowledge of Python. It doesn't run any code. We try to label it when it's running live code. And some of those there is some of that, but mostly you'll see lots of interactive stuff. Most of it works without Python because it's canned. Or it's captured. It's captured and replayed at your request.
Yeah, cool. Thank you.
Cool. If there are no other questions, I'll continue a little bit clarifying some things, and later I will show you exactly what David asked. This is like kind of near the end of the presentation. We'll get there. I see no one raising a hand, so I'm gonna go ahead and capture the screen. Okay. Okay, so I met James in the Austin Python meetup about, I think, 2 years ago or something like this, maybe 3 by now. And he was talking about all those nice tools, and I started using them. The reason I started using them is that I wanted some of the interactivity, because I developed disease models and I show all sorts of graphics there, and I need to somehow show more information. So he was showing some stuff, and I started to play with them. Later on, I started ditching old presentations. I rarely do PowerPoint presentations anymore. Today everything is made with panel. Why? There are some advantages. You can actually send it as an HTML. HTML can be read by multiple applications, looks more or less the same in all of those, but also it's interactive, and I use it to show posters. Today I don't show any poster. I don't print posters. I used to print huge posters like this. Each year at the NIH I'll go with a poster like this, just to give you an idea. Think about a poster. How much does it cost? Roughly $100 to print at this size. You can argue you can do more or less, but this is how it is. Today you can buy some tablets with, that cost less than this. And if you can put the poster on a tablet or on multiple tablets, you can now show it multiple times. And more or less you can exchange it and use the same hardware, and each time show a different poster. But more than this, the poster is interactive. At the end you put it on a web page, and yes, it's a web page. So I stopped doing presentations, and all my presentations now are in panel, very similar to what you see now. This is, I have like a dual touchscreen machine. Even without the touch, I go to and present it like this, and it attracts more attention than the other posters these days. And I believe that in the future technology will go away, will make it such that the old print paper and all those large posters will go away and people will start presenting like this. But it's about time, it will take time. So how do you get there? I'll start showing you a few things, and I'm going to show you the things that matter in order to present something like this. A lot of them James already showed. I'll try to skip some. If you want to see something specific, interrupt me and ask a question in between. The first thing I'm going to show you is how you install panel, and I'm going to use James's, and not only panel, HoloViz. I'm going to use James's code, actually HoloViz website. He's the head of the project though, so it's kind of his code, but there are very talented people who work there, and Philippe Rudigal is there, and he's like very, very active. But HoloViz itself is, usually when you install it, it's recommended you install use Anaconda. Anaconda installation command is conda. Usually you want to create your own environment. So here is an example where you create a HoloViz tutorial environment, and you specify the Python version. What James didn't tell you is that HoloViz supports multiple Python versions. I don't know which one's better or not, but I still use all Python 2 versions. Some of the things will not work on Python 2. Recommended if you start with Python 3.7. However, a lot of the things will work outside a different version of Python, even Python 2. Some of my code is really Python 2, and I use Python 2 a lot, and it still works, even though Python 2 is officially not supported. After that, you activate this environment. At that point, after you activate, you can install whatever you want. This is the installation command. Conda install from the PyViz channel. If you see PyViz, this is their old name. They changed it to HoloViz about a year and a half ago or something like that. So now everything is HoloViz, but you'll see some things that are PyViz. PyViz and HoloViz are kind of, they have an overlap, let's say it like that. If you look, for example, on the GitHub channel, you'll see it's still called the PyViz channel. You can still find them hanging around there. So conda install -c PyViz HoloViz. This is what it will install all the tools you need there. These are commands to run the example, and after that you can run the Jupyter Notebook. So this is the important command. Everything else is kind of setup. Let's go back to the presentation and let's start talking about HoloViews. Jean-Luc Stevens, one of James's former students, now he's created HoloViews. The way he describes it, if I quote him well, and I hope I quote him well, is that he saw all the mess with all the libraries and all the backends and tried to organize it in a way that will be easier. And HoloViews allows you to do multiple things. You've seen those examples of interactivity before. I'm showing here a simple plot, and what you see here in this entire presentation is a static web page. Meaning, if I give you the HTML file, even if you are not connected to the internet, you don't need anything else. Everything is recorded and embedded within. So if I touch this widget, it's interactive within the static web page. The static web page is a file. Think about it as something that captures everything you did. So you can see, you can change the sine wave, you can change the frequency, and you can change the elevation of the sine. It works a little bit slowly, but as you can see, things change here while I move the widgets here. This is what one functionality HoloView provides. The same functionality is provided by some other tools like Panel. Today, they made a lot of exchanges in the last few years, so a lot of the things are kind of like intermingled between the tools, and some of the HoloViz today is built on top of Panel, partially. In the past, it used to be a little bit different, but I won't go into technicalities, but there is intermingling between the tools. This is why I asked James to tell you which focuses each one of the tools. Let's go and look some of the HoloViews examples. So you'll get a gallery of things that you can show with HoloViews, and I'm going to just click on the reference library here. Notice one in the reference library, they have multiple backends. So James showed you at the beginning the entire ecosystem of Python graphics, and it's huge. There are many small libraries. From that subset, multiple of those provide graphics. Many people use Matplotlib. This is what most people use. I believe sometimes, not long ago, they said a huge portion, maybe a quarter if I remember correctly, of all of the plots used in Archive are from Matplotlib. This is what I recall vaguely some of the Matplotlib people talking about. This is by now, even though active, it's an old library. It doesn't have interactivity inside. Bokeh is a more advanced library that is tied to the web browser. Most of the presentations you'll see, the entire presentation in the HTML eventually is generated by Bokeh. And if someone asks a question on a web page, please unmute yourself and interrupt me. Otherwise, I cannot see the web page while I'm presenting the presentation. I heard someone on some beep. So anyway, maybe I'll just check it out in case there's something important. Okay, it's just James. Okay. Okay, so I hope you can still see the presentation. So HoloViz works with all the backends. Plotly is another plotting library they developed. Also has some interactivity features, so it's more new than Matplotlib. All of those backends are supported to some degree by HoloViz. What HoloViz does, it says, oh, you want to give me an area plot? Let's see. Matplotlib can plot it, Plotly can plot it, Bokeh can plot it. So it doesn't even know, but it will plot the area regardless, but then you just ask it, plot it with Plotly, plot it with Matplotlib, plot it with Bokeh. There are a little bit small variations on some of the parameters that you can push to any of those, but it will work with all of those. Now, some of the libraries don't support some things, like bvariate is supported by Bokeh and Matplotlib. It's not supported by Plotly, so Plotly will not be a viable backend. But you plot, when you work with HoloViz, you work at the top level. You just say, okay, I want this area, and it will plot it for you. And you can see how many of those primitives it can support. You can see simple primitives such as boxes or bounds, which are basically type of rectangles that you can define but differently. You can see more sophisticated things like boss whiskers. Here, something more sophisticated and interactive. It's called chord. all of those primitives are provided by HoloViz. So if you had once a matplotlib or a bokeh or a plotly-plot, you can easily migrate it to HoloViz. It's basically almost the same format, only much more powerful. James showed the heat map before, but you can plot images, histograms. Histograms are usually not a primitive you'll find in many of libraries. HoloViz provides it for you. It will provide the histogram for you and plot it. You cannot find it as a primitive in the library. You have things like rasters, like images. You can show flows by using Snakey. Scatter plots, this is what you're used to. There's scatter plots, but there's also points. They are very similar, only you define the data a little bit differently. You can plot a table. This is HoloViz, you plot the table. And then the table becomes semi-interactive. You can click on things and see things in it. You can plot meshes, vector fields, all sorts of statistical plots using violin. Many examples are provided, and more importantly, HoloViz provides you some basic functionality that allows you to combine those plots together. And I'm going to talk on a little bit a few of them. More than this, James didn't talk about it. HoloViz gives you the ability to use interactive data, streams of data, but also ability to edit data, like box edit. Or you can draw polygons if you really want. So those are things that are provided with HoloViz, and those are kind of primitives you can work with. I'll go back to the presentation, and I'm going to show you, I'm going to go link by link here and talk a little bit about the things that are possible to do. So we talked about the HoloViz library gallery. James talked a little bit about overlays. I'm going to go back and talk about it a little bit. So if you have two plots, any two plots, you can combine them by putting plots on top of each other. This is, think about it as you have transparent paper and you're just putting this transparency ones on top of the other. And it will adjust the axes for you and make sure things are compatible. And you don't have to worry about that. You can also control it and manipulate it, but this is more complex. The way you do it, you just create the plots, a curve and a scatter plot. This is the curve, this is the scatter plot, you create them. The only thing you have to do is multiply them. The new object is both plots together, and you can look at the objects later. So you can do an overlay this way. You can also do layouts. Layouts is the plus operator. When you do a layout, it will put the plots one next to each other. Think about it as a big row of plots. Now, to show this row of plots, you can have like 100 of them. It will go outside the screen. So there's a way to organize it. Is that it calls .cols. I'll show you to you in a second. But the operation is very simple. Just before we overlay them, now we add them. Curve plus scatter will make this pure plot that is adjustable. It will adjust such that the axes will be such that will be compatible to each other. You can manipulate other things. Now notice, you see this bar here? This is the default bokeh bar. When you use bokeh, notice how now both axes move. This is, HoloViz set it such that all the axes will be compatible. So when you move things, or when you zoom, I'll try to zoom, everything remains and is compatible, so you can actually see things properly, and you can wheel zoom. Everything is set so you won't have to worry about those, and you can actually explore your data very easily. So these are some of the advantages. However, it's not enough. HoloViz gives you more. I'm going to show you the next set of examples. This is how you compose plots. There are many ways, and layout and overlay are discussed here, plus a multiplication mark, and the same examples you showed before. However, remember before, if you have 4 plots, 2 curveless and 2 scatters, if you add those, there's a problem showing all of those. If you add those, they'll basically create a big row. However, if you do dot columns too, it will display it as a grid. Each 2 plots in 2 different. In each row has only 2 plots because you ask only for 2 columns. In this way, you can control some of your visualization. You can also look at the object itself. It's a layout object, and go deeper and ask for the original objects that created it. So you can actually explore the objects. You don't, those elements that you combined don't go away. You can actually go for them and ask only from those from the object and combine them together. And look at only one of them, for example. More complicated layouts, I'm going to skip a little bit, are done by the same overlay you did with the multiplication, you can now do with the overlay function. So if you have a list of plots, you just use HoloViz.overlay. HoloViz, HV usually stands for HoloViz, but you can just overlay them on top of each other, and all of the 4 plots from before are now all together shown in one plot. And as James showed before, you can make it interactive. But more importantly, you can group them and label them differently to show labels. All of those things are possible, and you can control them. And I think this is enough to talk about layouts for now. If you have more questions, oops, sorry. Here we go. I think I lost my original. Here we go. Here's the original. So, last thing is the HoloView plots are interactive. Let's look at. So here's a heat map. You saw them before, and you can move it around. However, this heat map doesn't tell us enough information. And notice you can have categorical axes, or actually heat map in this situation is only categorical, but HoloView supports both categorical and continuous axes. And the only thing you need to do to make it interactive so that you can hover over things, you just add the words, use the term is just add the word tools equals hover when you create the options for the plot. So the heat map of the object .opts will change options for the plot, such as height, weight, what color, if you want to show the color bar, yes or no, where you place the bokeh toolbar, and color limits. All of those are defined by options. The only thing you need to do to make it interactive is say, okay, add a hover is just add tools equals hover over the options, and then you get information on each cell. You don't have to bother any more beyond that, because all the data is already compressed within the plot, and the plot knows what it's showing for the hover tool. However, you can do things that are more sophisticated. So this is a good time to actually tell you, HoloViz has a Discourse web page. You'll see it at the end, but there are a lot of questions you can ask there, and people put some tutorials. I put a tutorial on how to define interactive hover plots, and here's an example you can actually use and plug in, and you can then manipulate exactly what is shown. So for example, if I show a sine wave and I talk about frequencies, I don't want to show 120, 1.25. I actually want to show, sorry, not the frequency, the phase. I don't want to show the number. I want to show how many pi's is it. So 1.571 is half pi. So how do I do something like this? It is possible. It's a little bit more complicated, but there's a recipe here that explains how to do this. So you can go ahead and look it up later. But it is possible to create a hover tool that has your own text in whatever data you show. And one more thing that is important is the interactive multidimensional plots. James already talked about it or showed some of them. And notice all of the commands, like in this case situation I'm talking about HoloMap, all of the commands HoloViz uses shows you which backends it supports. Not all commands support all backends. So the HoloMap will allow you to take a list of signs, a list of sign functions, and convert them to the interactive plot you see here. The only thing you need to do is take this list, and actually it's not a list, it's a dictionary, because you have to tell it according to what you have to tell it what is the what to show in the as the label here. So for example, the frequencies here is F. So for each frequency, you give the appropriate sine wave from the sine waves you created. So this way, it knows frequency 0.75 is a certain sine wave that you applied 0.75 to. And it builds automatically all of those for you. It will know whether something is categorical. Here's an example of a categorical axis. Sorry, a categorical option. So, or a continuous one. If you have text and you can add text, I'll show you some examples. We actually use text for those. Then it will bring a list box for you. It will know it for itself, and it will do it for you. You really don't have to worry about it. Okay, so this is how you create multi-dimensional plots. Let's talk about how you assemble all of those things together. So this is where a panel comes in. And actually, before I go here, let's go back to the HoloMap and just say that there's also dynamic maps. The difference between HoloMap and the dynamic map is that the data is how you define the data. With dynamic map, you can have a web server that you will ask the web server all the time what to show in the dynamic map, so you don't have to rely on those intervals that are fixed. You can have them more continuous. But there are other ways to create layouts, and I'm going to show you another web page. Let's go there now. And there are multiple commands to do this, and as you can see, you can move those around, but there's also you can put things in grids. So there's a command called grid space that will put you things in a grid for you. You just give it the array of plots, and actually you can use holomaps with it. So you can actually give it the holomap and it will do it for you. So there are many more things it can do. I'm going to skip to panel because time is a little bit running out, and I want to show you some panel and leave time for questions and show you some more examples that are out there. So up until now, James showed you all the ecosystem, and I showed you some specific primitives that you can actually create plots. However, how to create a presentation like the one you're seeing now, which is interactive and you have all those capabilities? Well, this you don't really do with HoloViz. If you can, it will be very hard. Some things you can. To do this, you have to use panel. Think about panel as a way of arranging all those things together. And panel supports many other ways to bring you visualization, and those visualization also include text. So the simplest thing you do with panel is put markdown text. The same one you write documentation for your libraries, you use markdown text. And some example, the way you use panel is you have to import panel first, but after you imported it, usually it's imported as PN in the documentation. I like just say the explicit name of the library panel. If I put panel and I put in all of this text in quotation marks, I can just use markdown. So you can use a big title. You see it here. This is the heading. You can see it here, a subheading. And of course, you can use the entire markdown that is supported. There's a markdown library that sits underneath that supports also extensions. I'm going to show you later what it can do. You can use italics, bold, and code. Code is very interesting because markdown will if you put code not like this is an inline code. If you actually put code is 4 of those carets, I think it's called a caret. It's not a quotation mark, it's what you have on the left of your 1. If you press shift on it, then you get this wavy sign. It is still the wavy sign. So this caret, if you put 4 of those and then immediately put the name of your language, like C++, Python, JavaScript, it will color the code according to the way that you put this. So I know some people were showing in Combine need to show code annotated. Well, if Markdown already supports this annotation, then you can use panel to display it. You can add links. This is just like you do in Markdown, and this is a link. If I press it, it will go to the HoloViz website. And of course, you can use plain text. So you can write text. This is the very basic panel object. And you notice I used panel.panel, but actually pane.markdown, this is what brings it to you. When you say panel.panel, panel will try to identify the object you gave it to him. You gave it, and then a panel will use the most appropriate one. Let's go to plots. So you can plot data. So here's data cohort by year, and I'm showing you how many cohorts my model did for every year since 2012, and I'm showing it very nicely here, very easily. The way I do it is I create a HoloViz plot using scatter, very easy to do, and then I say give me a HoloViz pane, and notice I say panel give me a HoloViz pane of a certain height and a certain width. You can add those information to panel, and I also tell it use as a backend plot matplotlib. What it will do, it will create a plot using matplotlib and give me the image back. Notice this is not interactive because I asked specifically for matplotlib. You can do the same thing with bokeh. Usually when you use bokeh, it's a good idea to do HoloViz.extension bokeh, so HoloViz know, oh, I'm working with bokeh and I can do this. You do the same draw commands, only now I'm using HoloViz bars, and now instead of, I also ask it to rotate the axis of the text in the years vertically. You do this by X rotation. I also added tools equals hover. So notice, the minute I add tools equals hover, it will immediately give me the information. It doesn't matter which type of plot, it will figure out what you mean for you. Then the only thing I do is I create the panel. The panel displays the HoloViz objects, and this time it uses bokeh. We're scientists. Well, scientists use LaTeX to put equations. How do you put equations? So about, I think it was a year and a half ago, I started bothering the team, the HoloViz team, and I'm quite bothersome when I send them email. no, actually not an email, you go on their channel and you ask for also questions, and they were very, very helpful and helped me with the LaTeX solution. So you can do LaTeX, and there's a pane for LaTeX. More than this, they added two types of backends, MathJax and Katek. So you can use LaTeX with, and it will be rendered either by Katek, I think Katek is the default now, and MathJax, and you can actually ask for one or the other. The way you put it in a pane called LaTeX, and you embed the text you want to put in LaTeX with dollars. So now you can see it's LaTeX text. You can do this also with parentheses after a backslash, as you can see here. You can write equations like e equals f, some more complex equations. Notice it will adjust by size as much as it can, and you can also control the size. Now, beyond the size, you can control many other parameters, and this is good time to tell you what panel does. If it sees an option, it tries to push it down. If it recognizes it, will try to push it down towards towards its backends. So different backends may have different ways to describe their options, because Matplotlib doesn't describe the options the same as HoloViz. But in this situation, I'm using the style here, and you have to define it as a dictionary, and the dictionary says for font size, here 16 points. This will be passed back to Katek and MathJax. I'm going to check. Yeah, things seem to be still okay here. No questions so far that I see. So I'm going to go back. So LaTeX is supported, and you can actually create presentations with equations, and sometimes you do want to show them. Now, if you want to do something more sophisticated, you can use HTML. So you can use simple HTML using tags. This is within Markdown. You don't have to tell it even. You see, I'm using panel.panel. And this is how you, for example, color text. Markdown does not support color, but you can use HTML to enhance. More importantly, if you put a link that you want to, with the hover information of a hover tool on top of it, you can do it using HTML. Or you can take an image and embed it within the HTML. This is wasteful, but if you want to send someone an HTML file with all the images inside, this is how you do this. You have first of all, you bring in the image, then you construct an HTML image anchor. The image is now encoded as base 64, and the HTML for it is this. And this will push the image such that the image will work offline, and you don't have to give the entire directory structure. You just give the HTML file. It has everything in it. By the way, panel will do this for you. There's image commands as well, but this will also allow you to, if I click on the image, to bring you to the website that actually does this, and this is HTML, so you can actually embed it with HTML. I'm showing you this elaborate example to show you that you can do wonderful cool things with HTML alone, even if you're not using panel as panel. You can actually embed HTML, and you can do much more. Tables. There's multiple ways to do tables. One of them is using panel, use Markdown. So first you might want to define a CSS. This is something that doesn't work. They introduced it is supported by panel, but it's kind of tricky how to do this. If you're doing it, then you better know your HTML. For me, I needed help, and the panel team helped me out and told me, here, you can use this CSS to color your table. Otherwise, if you use a Markdown table, you use whatever default CSS you have there at the time, and the table may show either different lines, different colors, because Markdown will inherit whatever you used. So to make sure that you color it specifically, you have to use those commands and tell panel that you're using this this specific table. So panel, I use the CSS table called special table that I defined here. However, there's an easier way, much more interactive. You can define tables. You can actually use panel data frame, and data frame will show you an interactive table like this. In this situation, you might want to remove some elements. Actually, the code here, I think there's a bug. There's if you use the code over here, it will add you an index. You have to remove the index, and actually I'll show you how it's done here. I'll show you. And this is the documentation, and you have to say index equals false to actually run this. So the command here is panel pane data frame, and then index equals false to actually generate this. So hopefully this correction is enough. Now, why do we do all those panel things? Because we can arrange them in any order or any way we like. So I created those two plots you saw before, the scatter plot and the bar plot. I also created, I used the figures used for plot 1 and plot 2. I also created two labels called scatter and bars. Those are plain text. Now I can mix them in different ways. The way you do it is the command panel row and panel column, and what I'm showing you here is panel tabs. Actually, this entire presentation is based with tabs and tabs inside tabs, and you can see tabs inside tabs inside tabs. So this is how I navigate the presentation using the tabs command. So think about this moving slides, very easy. So if you arrange the figures in a row, figure 1 and figure 2, this is what you do. This is what it will do for you. If you arrange them in a column, this is what it will do for you. Those are the same plots as before, only notice now I'm not using matplotlib, and the plot is interactive here. You can usually see this because you have this bar over here, the bokeh bar, because I'm using bokeh as a backend. I'm no longer using matplotlib as a backend. Or you can mix things. How do you mix? So here I'm saying panel is a row of what? Two columns. One of them is text 1 and fig 1. So the second one is text 2 and fig 2. And now it's a row of two columns. I can do the same as a column of two rows. Each one is scatter in the plot, and the text and the plot. Basically, that's what's shown here. Finally, how do we make these tabs work? Very simply, I take the panel objects I created before. I just said them, look, this is fig row, and notice the text here corresponds to the figure that I created. So all of those that I created before, I just put them, and this is the way I navigate very easily. Now I'll come to the very nice part, and this is something that those guys did amazingly. Each panel object you create, but actually HoloViz object as well, but each panel object you create can be saved to an HTML file or to a different format. You can actually save it as an image if you want. But the nice parts are the HTML parts, the ability to actually show it as an HTML. And the way you do this is you just say the object, here's the object that I saved before, the tabs object I created before. I just save it and I tell it, this simple command will already create this tabs for me, and I'm going to show you here. If I click on this, I can see this is the same thing that I saved. Now I want you to look at the size of the file. It's tiny. It's like 58 kilobytes. Why? Because it didn't embed anything. It put all the bokeh information. Online. So whenever I clicked on that file, it got out and brought the bokeh information from a different server, the bokeh server, and then it just showed the plots, very tiny. However, if you want everything in line such that this HTML file is a document on its own that basically archives everything, you need to do a few more things. One of the things you have to do is put the bokeh resources in line in the HTML code. It takes like a megabyte or even more. Then you have to, when you define it, you might want to also define embed. In some versions of panel, embed is false. What embed does, it takes the it snapshots all of the sliders in each one, all of the sliders and all the combo boxes, such that if you when you will move them, it will know what image to display interactively, and then it creates the entire space of options. It embeds in the HTML file, so now it is static, and this is how it works. So if your state space is huge, you have a problem and you'll have a huge file. Some of the files I'm using are like almost 100 megs. However, today there are servers that will host 100 meg static file and will show it to you. You might need today to add some JavaScript code to upload it. Very simple, and I can show examples, but generally today you can actually handle all of those files, and a lot of my information today is when I publish things interactive plots that are actually static HTML plots. And of course you can add the title. Here I add fully reproducible. Let's go and show you this again. Here, this is the full size. Notice it's 1 megabyte in size. And when I go there, it will show me fully reproducible as the name. So you can actually add the name. So there are multiple options actually in the save. And I discussed them in one, sorry, I have to, here we go. I discussed them in the tips page. I was extensively using this option. As James said, I was overusing it to whatever panel was initially designed for, but they were very, very helpful and actually allowed me to do this. I very much, if you plan to use some of those tools, talk to the development team. They are very friendly. So here I show an example of sorry, this is not my example. This is again the HoloViz Discourse webpage. I show an example, and this is the save command. You can see there are many options. You can actually even dump JavaScript files that outside the HTML to make it look smaller or nicer. You had the option of max states. I don't know how much is the situation, but you can actually limit how many states you have in case the files are huge. Some of the files I'm generating sometimes takes hours just to generate the HTML. Once you generate it, the HTML is fast, but only the generation can take hours. So there are many options, and the resource one I talked about, this is the one that's important. Resources inline will make it all static for you. And I show here the example of the file, of the image file you showed before, that you can make interactive and discuss why, and discuss elements of how, what to beware, what to do, and what are your options. I must say one more thing. Those guys are all the time extending their capabilities, and it's hard to catch up with them. I mean, with the developers. They are very fast and very good in what they're doing. So this is why I'm using those tools. I've been using them for a few years now. I think maybe 2 years now, something like that, maybe more. And you will see many presentations. I've done them with them. Some have videos, some have not. Again, I want to help thank the development team, Philippe Rudiger and John Stevens, and of course James Bednar, who you've seen before. They support their users. Very useful, very good support they give. I want to show the GitHub page. I'm going to click here. I'm not going to log in, but I'm just trying to show you that this is a snapshot of some of the few last conversations that they had. So go to gitter.im.pivis/pivis/pivis. If you log in, and you can log in through your GitHub account, you can go and ask them questions online. They answer very fast. They're very useful. And give you the answers very quickly many times. They also have a Discourse channel. I showed 2 topics, but the number of topics is going fast there. This is where you can find some more support, and you will see this is what people currently are plugging there. And this is, you can see, pair one of the tools that they use. You can go and find information of how much topics, and you can see it's fairly active. Panel seems to be very active, probably because of those capabilities that I'm talking about, being able to present a fully functional interactive HTML page, which is actually static. I think I have like 15 minutes for questions, so I'm going to start now and ask questions. If there won't be questions, I'm going to show you some presentations, some other nice things I've done with this, so to give you an idea, so it will be recorded. So I'm going to go back and see if there are any questions. David, did I answer your question from before with the save?
You more than answered it, yes, thank you.
So anyone has any other questions of the things I've shown? I was skipping things, and
I think it's a good pointer to dig in and have a play.
Okay, so I'm gonna keep a few more. I'm gonna stop the recording after this, but I'm gonna show you a few more things I've done with this. Maybe it will bring in some questions of how you do things. So if you click on each one of those, again, now they're all on the web, all of those presentations, so you can actually go and click on them. So I'm going to show you a presentation from AnacondaCon. I think I have to find which one of those windows it opened, because I was clicking. Not this one. Let's try. Maybe it didn't upload, so I'll try it again. Okay. This is a presentation I made in AnacondaCon, so we can see images. It will take a while to load. This is an interactive presentation with the much earlier version of Panel. It will take a second to load because it's loading quite a bit of data. And here, this interactivity, this is actually bokeh plots, but I embedded them all in Panel, and you can actually go and see. This is ICU data for one patient, for example. All interactive, and some machine learning techniques. You can put images, you can put videos. All of this in Panel. I did this using HTML, but it is still possible to do in other ways. Let me show you something. Yeah, you can show interactive maps like this very easily. You can also I'm not showing it here. I'll show you another presentation where I actually show much more. So maybe I'll go back. As you can see, it loads my presentation now. It's a static HTML page. It takes a few seconds, but it works. Here, this is a poster, interactive poster, as I showed at the NIH. So notice the poster has two parts. It's interactive, so there's two posters in one. So you can actually use the tab to look at the other poster. You remember I told you can put combo boxes? You can do this with HoloViz. This is actually a disease model and it's fully interactive. You can see the clinical trials and you can hover over them. Very easy to do and generate this. You can do more. You can actually put an entire website. This is a website embedded. So I'm actually now going to my unit website, clinicalunitmapping.com. This is the other thing I do. And you can actually look in the clusters of units and interact with the website, because you can put an HTML object with one line inside panel, just using HTML as I showed before. What else can I show you that's interesting? Data shader. I'll show you data shader. This is something that machine learning people would love to see. The minute it will return to the... Here we go. Here, I'll show you a presentation I made recently for PyData. This presentation takes a while to load. It's a big file. However, once it loads, it will show you everything, and actually you can follow all of those through the website. As you can see, I just dropped them on GitHub.io. Today there's a limitation. I today dropped big files on Netlify that's able to handle bigger files for free. So at least I'll mention them because they do good if we give a free service. So you can see a presentation that I showed in the NIH, but the reason I'm showing you here is because it will show a few more advanced features that HoloViz tools can give you. So this HoloMap, now you should know that it's very easy to generate. It's a few lines of code. This is that HoloMap. This I'm talking about 25,000 different units. Here I'm taking 30 units against 30 units and generating a HoloMap that's interactive. How do you show for 25,000 by 25,000 matrix? It's a proximity matrix here. This is how it looks, 25,000 by 25,000. I'm using data shader, and notice I can hover all of those and it will give me the value. This is something that you cannot do, and I can mix it up and analyze the data and show it like here before clustering and after applying machine learning. So now you can see the data is much more ordered visually. There is no other tool that I know of that actually can show you how things like this get ordered visually. It's very, very hard. It's done fairly simple. It's a few lines of code with HoloViz. Actually, very easy. So this is done by integration of data shader, the tool that James showed before to show all those huge maps of the United States and the earthquakes. Now it's showing a matrix. How do you show a huge matrix to see where the zeros are or stuff like that? This tool can help you. So this is one example. Another example. Look at this. This is a neural network that I'm learning, but I'm using multiple types of neural networks, and I want to see which one of them learns better or more or less, and I can add hover information. So now I can actually compare those neural networks much better, and I can add multiple plots and figure out which category they are better and why very easily. Otherwise, it's just looking at those numbers, it's mind-boggling. But more than this, this is how the neural network learns. This is how well it learned over time. This is how many epochs. This is what happened inside the layers of the neural network. So some people claim that neural networks are black box. In a sense, yes, you don't really know, but you can really visualize what happens there. what you see here is the time axis. What you see here are the neural units and different layers, and you can actually figure out which of those change through time. You can see those changes. They seem to be slight, but this is how the neural network actually learned, and you can see what changed and what does not change and what remains constant, more or less constant. And you can do this very easily with Data Shaper, and you can actually look at the recurrent layer, you can look at the kernel, you can look at the bias. All of those are provided for you. You can look inside, and with Data Shaper you can actually plot that. So I think I've done showing things. Maybe I'll show this. This is something that's done with HoloViz tools. This is not necessarily Panel. Panel does the saving at the end. This is mostly HoloViz, but this is a disease model. This is the my diabetes model, where you actually see how the model trained over time, and you can actually go and visit and see all the points what happened. It's available online at that link. I usually, when I today publish a paper, I publish a reproducible visualization of it. Each one of those is a clinical trial, and the height here shows you how well the model does this, represent those. Basically, I'm showing you the error for each one of the clinical trials from the model, and you can see how the error drops the more I learn the model. And the bars here, it's an ensemble model, so the bars here show you how much each model contributes to the ensemble, to the best representation. And you can see things like outliers and variations, and what you can see is actually sensitivity analysis. So those are things you can do with Panel. I'm going to show you at the end the QR code. Again, this is how you can download this presentation. And after you download it, you can actually find the code that generated this presentation. Is available in this GitHub page. So this is my GitHub. I put all of the presentation here, and you can actually go and see all the code. Now notice I had several versions here. Some of them I made sure that they are, this one is delivered under Creative Commons license because I wanted to show the combined logo, but the first version, which is very much similar to this one, is available under Creative Commons 0, so people can use it and do whatever they want with the code. No questions asked. So hopefully this will help you. There's some information here, and you can actually go and see how this entire presentation was generated. I typically do this for my other presentations under different licenses. If you want something specific and you want to use some code, send me an email. I'll be very happy if it's used. So at this point I'll stop presenting. And it's only us three who survived, but I'm happy I did this. I'm going to stop the recording in case someone has a question wants to do outside the recording, but thank you for surviving it so far.